a transformation for our parent functions. So here is our parent function, f of x equals the absolute value of x. So this is the parent in the blue, your absolute value function. And now we have a transformation, the child, g of x, equals the absolute value of x minus 2. And what we want to figure out is, what is happening with that minus 2 from the equation above, okay? So let's figure out where that minus 2 is happening. That minus 2 is happening inside the function, inside the absolute value. And it's a minus 2. So if we go to our purple slide, I just made this white to make it a little easier on the background. It's inside. We have to think opposite. So minusing h is going to go a horizontal shift right h unit. And then what we do is we take all of the x values and we're going to add h, moving those x-axes to the right that many units. So let's go back now. Let's verbalize it and write the rule. So verbally we say it's a horizontal shift right 2. As a rule, our original ordered pair would be this, and now every ordered pair with the x is going to change. It's going to be plus 2. So you have your x, and now we're going to add 2 to every x value. So there's our rule. Now let's go down and graph our parent and then our transformation. So our parent we'll do in the blue, f of x equals the absolute value of x. And in the purple, g of x equals the absolute value of x minus 2. All right, what we have here in this first column are your domain values. We're going to stick with the same 5 numbers a lot throughout these problems. Negative 2, negative 1, 0, 1, 2. So we're going to take the absolute value of negative 2, plug it in, and we get 2. The absolute value of negative 1, we get 1. The absolute value of 0, we get 0. Absolute value of 1, 1. Absolute value of 2, 2. So this should look familiar to you. These are 5 points that will help create your absolute value function. It's your parent. All right, there's your parent, f of x. Now, our rule says, if we come back up here, every x value, we're going to add 2 to it. So I say x plus 2. So all of these numbers in this column, we're going to add 2 to them. So if you want to do it in your head, that's great. I'm just going to write it out for you. So negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. All right. Now, all of our y values are not going to change. So all these numbers are going to stay the same. So 2, 1, 0, 1, 2. All right, let's go ahead and graph these now. So we're graphing these ordered pairs. So the first one is over 0 up 2. Next one is 1, 1. Next one is 2, 0. Next one is 3, 1. And then the last one is 4, 2. So now there is our new graph shifted to the right 2 units from our first parent function. The domain is what type of numbers can you plug in for x. For the absolute value, every number works. Negative fitting to positive, everything's showing up. But now for our range, if we think about our range, y values, going across that y equals 0, it has to be above that line. So we say for that is y equals greater than or equal to 0, and we're only worrying about the g of x function, the domain and range.